Our next presenter is Almog Alay Raz, CEO and VP R&D of Corneat Vision.
Hi, good afternoon. I'm honored to be here today and talk about Corneat Vision. Corneat Vision started 7 years ago as an artificial cornea company. But since then, we've extended our portfolio in order to capitalize on the core platform material technology originally developed to permanently integrate a synthetic lens with ocular tissue. We call it the Corneat Ever Matrix. It holds the future for a new era of medical devices. The Corneat Ever Matrix is the first and only synthetic, non-degradable material that seamlessly integrates with resident ocular tissue. We've proven it can integrate with soft tissue, but also with bone tissue, and it has many applications across a diversified field of medicine. When implanted, the Corneat Ever Matrix practically goes under the radar of our immune system, triggering cellular proliferations that leads to full colonization and integration with the tissue. It's not a scaffold, it's more like a rebar mesh as it stays within the tissue for life. Today we have 3 products in the ophthalmic space. An artificial cornea that leverage an Ever Matrix skirt to permanently integrate with the ocular wall. The Corneat Ever Patch, which was just FDA cleared, that displaces the use of donor and processed tissue in ocular surface surgeries. And the Corneat eShunt that leveraged this capability and additional innovation to provide for the first time a long-lasting and efficacious solution for severe and refractory glaucoma patients. I'll start with the Corneat Ever Patch. The Ever Patch can be used for several ocular surface surgeries. Here, for example, it is being used to cover and conceal a glaucoma drainage device and protect the conjunctiva overlying it and avoid what is called tube exposure. This device is only 100 micron thin, it's synthetic, it cannot carry disease, and it displaces the use of tissue from eye banks, which is processed, and it's much more easier to use. The main advantage is it is non-degradable and stays on the ocular wall for life. The device was just FDA cleared a few months ago, and we've provisioned the first 120 devices to 25 ophthalmic centers in the US. Here you can see our first patient, whereas one eye is implanted with a sclera from the eye bank and one with the Corneat Ever Patch. All the eyes with the tissue patches were congested and inflamed, while eyes with the Ever Patch were quiet. Another advantage is, of course, the aesthetic of our device. You can hardly see it in regular vision. Histologically, we've proven that it's much better than tissue here on the bottom left. The second product is the Corneat eShunt. The Corneat eShunt addresses the shortcomings of existing glaucoma drainage device, which clog at a rate of 10 to 20% a year. Using 100 micron lumens and resistance to flow, we are able to reduce the pressure in the eye to about 10 millimeters of mercury, stopping the progression of this devastating eye disease. The design of the shunt allows it to integrate with the subconjunctival space as it traverses through that area, and its outlet is extended deep into the orbit in an area that has only fat and blood vessels, and it's less likely to fibrose. We've just completed the R&D process of this device and did 3 compassionate implantation in 2 dogs and a cat with very high intraocular pressure that were not responding to medication. And we practically saved the vision of these 3 pets. We are planning to start a first-in-human trial later on this year and a pivotal trial early next year toward a 510(k) clearance in the United States. Lastly, the Corneat K-Pro. This device basically leverages an Ever Matrix skirt in order to permanently integrate a perfect optical lens with resident ocular tissue for life. The surgery procedure is relatively straightforward and can be taught within a few hours. Here you can see how it is being implanted. Using 3 safety sutures, we approximate the device and tie it to the eye wall. By leveraging a special spatula called a snapper, we fit the corneal stump into a posterior undercut on the back of the device. The surgeon then just needs to cover the skirt with the conjunctiva and let the biology do the integration. On the right, you can see our first patient, which was operated 3 years ago and regained his sight following 10 years of blindness. Here you can see the integration of the skirt within the eye wall. There is no capsule formation, and the material gets filled with fibroblast progressively. We've completed a first-in-human study a year and a half ago with 10 patients around the world. 3 of them are now 2 years post-op. We've learned a lot. We improved the surgical technique, pre- and post-op treatment, and I'm happy to announce that today we will be starting our pivotal trial with the first 3 implantations in South America. The idea is to do 25 implantations outside of the US and 15 patients within the US, so the device will get approved within 2 years. We have a very busy plan in order to approve all our 3 products globally, as you can see here. But the idea with the artificial cornea is not to provide a secondary solution to corneal blindness, but continue and approve the device as a primary care device for global corneal blindness. Thank you.